Hey there, I am Mia. I will be your guide to walk through this demo. So now please choose your preferred use case from the options provided. For now, we will select the loan payments use case. This is the upload method page. Here a list of APIs are provided. You can select as per your need. For now, we are selecting standard file upload method. Here, upload your CSV or JSON files. Here, select your desired flexible feature engineering method. We have three options: standard, flexible, and custom. Here, select your file which is necessary to go through aggregation process and click Submit button. Now choose your primary key for the aggregation of your data to create a master data. Now here you can see your aggregated data, and you can also download your aggregated data from Download button. And if you are satisfied with your data, click Next button. Now choose your target label, which you want to optimize. Now select Good Bad Outcome, whichever best suited for your target label. And finally define your target labels. SriyaSXI technology generates actionable insights based on the outputs from a target decision tree. These insights can suggest improvements, such as an X% increase in a desired outcome. However, these insights might be unclear, so users can provide business context at 3 levels to help clarify them. The SXI-powered Jupyter system will then offer enhanced recommendations, which can be useful for improving business operations. Welcome to the Sriya dashboard. Here, the Late Payment Risk Index indicates the use case selected by the user, which is incorporated with Sriya Expert Index. Sriya Expert Index, SXI, dynamic score/index obtained from a proprietary formula consisting of weights from 10 AML algorithms. SXI is a super feature and is a true weighted representative of all important features. Converts a multidimensional hard-to-solve problem into a simpler two-dimensional solution. Problem solved. Currently, the SXI score stands at 0.97, which effectively distinguishes between on-time and late payments. In the system, on-time payments are highlighted in green, while late payments are marked in red. A higher SXI score, such as the current 0.97, indicates a greater likelihood of late payments. The accompanying pie chart provides an overview of the current loan status within the dataset, showing that 50.2% of payments are made on time, while 49.8% are late. This visualization helps to understand the overall distribution of payment behaviors. Additionally, a correlation graph with an R-squared value of 1 highlights a strong relationship between the SXI score and late payments, indicating that as the SXI score increases, the likelihood of late payments also rises. Presently, with the SXI score at 0.97, the late payment rate is 49.85%. If the SXI score is lowered to 0.90, we can expect a reduction in late payments from 49.85% to 39.86%, representing a 20% decrease. This adjustment shows the potential for improvement in the short term. Looking at future improvements, if the SXI score is further reduced to 0.78, the rate of late payments would drop to 25%. A significant 49.8% reduction, indicating midterm progress. For long-term improvements, lowering the SXI score to 0.67 could reduce late payments to 10%, achieving a substantial 79.92% decrease from the current levels. These projections emphasize the importance of managing the SXI score to improve payment behaviors effectively. The slide presents potential business improvements, particularly focusing on reducing late payments. It starts by highlighting that the current number of late payments is 25,816. The data shows significant reductions across 3 timeframes. An immediate reduction of 20%, which means 5,163 fewer late payments, a midterm reduction of 49.80%, equating to 12,856 fewer late payments, and a long-term reduction of 79.92%, translating to 20,632 fewer late payments. In addition, the slide compares the performance of 3 different models: AutoML, SXI, and SXI++. The comparison is based on key metrics: accuracy, precision, and AUC, area under the curve. The results indicate that the SXI++ model outperforms the others, achieving nearly perfect scores with 99.99% accuracy and precision and an AUC of 1. In comparison, AutoML has an accuracy of 84.52%, precision of 86.29%, and an AUC of 0.92, while SXI scores 88.07% in accuracy, 90.22% in precision, and 0.93 in AUC. The receiver operating characteristic ROC curve is displayed, which plots the true positive rate against the false positive rate. The model achieves an area under the curve, a UC score of 1, indicating high classification performance. After the ROC curve, a confusion matrix is shown, summarizing the model's predictions. It reports 5,198 true positives, correctly predicted on-time payments, 2 false positives, incorrectly predicted on-time payments, 0 false negatives, missed on-time payments, and 5,163 true negatives, correctly predicted late payments. In the actual versus prediction table, individual examples of predictions are provided, showing the ID, SXI score, actual target, either on-time payment or late payment, and the model's predicted target. This table highlights specific cases, indicating the model's accuracy and the SXI score associated with each prediction. Finally, at the bottom, 2 decision trees are depicted, one for current late payments and the other for target late payments. These trees visually represent the decision-making process used by the model to classify payments as on time or late, helping to understand the factors influencing the predictions. The target decision tree outlines the key factors that need to be addressed to achieve a 20% reduction in late payments. This reduction will lower the late payment rate from 49.85% to 39.86%. The tree helps identify specific areas for improvement and guides actions to minimize the incidence of late payments effectively. This section displays the results of a sensitivity analysis, which compares actual and adjusted values of key features to assess their impact on loan status. The analysis focuses on top 5 features: installment, last payment amount, total received late fee, delinquency amount, and total payment. This analysis helps in understanding how changes in input variables affect the outcome and can be particularly useful in predicting the effect of adjustments on a system or model. The analysis demonstrates how changes in these specific features can influence the prediction of loan status, shifting it from late to on-time payments. This shift suggests that increasing the installment and last payment amounts can significantly reduce late payments, as reflected in the model's predictions.